All right, so today we're starting off with 4.2, simplifying fractions. All right, so we're starting off talking about factors. A factor of a number is a non-zero number that can divide into it evenly. All right, so when we look at factors, say we're looking at factors of 12, it'll be 1 times 12, 2 times 6, and 3 times 4. So if they were to ask you to list them, normally they ask you to list them in order, 1, 2, 3, 4, 6, and 12. All right. We could have wrote this better. And always remember, if I scroll it too fast, feel free to, raise your hand on mute so I can roll back down, let you see it. So factorizations, let me write this better. All right, so it says find 4 factorizations of 12. So this was the first exercise that you may see, or one of the first exercises you may see. If they ask you to find 4 factorizations of 12, we just finished talking about 1 times 12. Let me go purple. 1 times 12, 2 times 6, and 3 times 4. But also 2 times 2 times 3 is considered a factorization of 12. In other words, you break it down all the way to just prime numbers. 2 times 2 times 3 will multiply back out to give you 12 as well. So if they want all of the factorizations of 12, notice the difference in the directions. The factors of 12, 1, 2, 3, 4, 6, 12, but then the factorizations of 12. So make sure you watch the directions and how they're asking of you, because a lot of people get those two exercises mixed up. Asking for the factors, and then asking for factorizations of 12. So that's the difference in the two. Before we go any further, is everybody okay with the difference between the two? How they're asking you, the key word is factors versus factorizations.
Yes.
All right, appreciate it. Hold on 1 second. All right, so let's go up. Prime numbers. Numbers that are only divisible by 1 in itself. So they're your list of the first few prime numbers: 2, 3, 5, 7, 11, 13, 17, 19, 23, and so on. Number goes on to infinity. Composite numbers, just any number that's not prime. So basically, if there's a number that can be divided by something else other than itself, then it's composite. So 4 and 6, 2 can divide into both of those. 3 can go into 6. 16 or 2 can divide into 16. 8 can divide into 16. 4 can divide into 16, and so on. If there's another number that can divide into a number other than itself, then it's not prime. It's considered composite. All right. Next thing, prime factorization. It's the representation of a number as a product of prime numbers. So I'll show you what I mean in a second. Giving people a chance to write. So product means multiplication. So when we go back to 12, that last factorization that we talked about was actually a prime factorization. So we have 2 times 2 times 3. Notice that all of these numbers are prime numbers. And when you multiply 2 times 2 times 3, it gives us our 12 back. So it can't be the prime factorization of a number if they're all on prime numbers. And then when you multiply them back out, they don't give you what you originally had. Also notice the other way that we can write this prime factorizations. If I have a number repeated, I can use that as an exponent. So if I have 2 times 2, that means 2 squared. So I can write that as 2 squared times 3. So either one of those would be fine to write as your answer. But if it says write, with exponents, then this one would be the one that they want. Looking at that 21, prime factorization of that is just 3 times 7. Both of those numbers are prime numbers. And when you multiply them together, they give you 21 back. All right. Any problems before we go to the next one? All right, so find the prime factorization of 220. So the best way to do this, and let me erase some of this stuff so we can walk through it. All right, so set up your tree. You got 220 here, and you ask yourself what two numbers will multiply together to give us 220. The easiest way to handle a number that has a 0 in the back is write that as a multiple or multiplication of 10. And so what I mean by that, you can do 22 times 10 because you have this 1 0 in the back. If I had a second 0, then that would be 22 times 100. If I had a third 0, 22 times 1000. So that will always be the case whenever you have zeros in the back. You can use those as multiples of 10. All right. Then 10, we know is 2 times 5. 22 is 2 times 11. All right. Questions before we look to finish it off? And you know you're finished when you look at the end of each branch and you see a prime number at the end of each. So 2, 11, 2, and 5 are all 4 prime numbers. Then you will write it as 2 times 2 times 5 times 11, or since 2 appears twice, you can write it 2 squared times 5 times 11. All right. Let's look at another one. So since 198, looking at 198, let me erase this. Looking at 198, you may say 198 is unfamiliar to you, but if 198 is even, then you know if nothing else, you can take 2 and divide it into it to see what other number times 2 will give you 198. So if you use 2, that would be 2 times 99. And so it's all about using numbers that are familiar to you. Like I said, if nothing else or if all else fails, you always can start off with 2. If 2 don't go into a number because it's odd, then you should next move would be 3, and you just go from there until you find a number that's going to a prime number that's going to go into this number that you're trying to break down. 99 is 9 times 11. Now 11 is prime. 2 and 11 are prime. And so you break down the 9 into 3 times 3. And so that'll put you at 2 times 3 times 3 times 11 because both those 3's are prime. And you also can represent that 3 times 3. That's 3 squared. Any questions? I think we got one more before. Yep, we got one more. And so the next one, 153. You're breaking that down where you could have started with. We see that it's not even, so you wouldn't start with 2. But if 153 is not familiar, you just start with 3, divide 3 to 153, and see if it goes into it evenly. And we see that 3 does. And then with the 51, that's 3 times 17. And that means that factorization, that prime factorization, would be 3 times 3 times 17, or 3 squared times 17. All right. So before we go to the next exercise, any questions on breaking down prime numbers? And so also when you look at these, the more you do it, the more you become familiar with it, the more easier they'll be to you. So just comes with a little bit of practice. All right. Equivalent fractions. And so when we talk about equivalent fractions, we're talking about this type of relationship: 1/2, 2/4, and 3/6, all equal to 0.5. If you were to put them in a calculator. So how do you test your equivalency? Be through the cross product relationship. If I have A over B equal to C over D, if I were to take my denominators up and multiply them to the opposite numerator, A times D will be equal to B times C. If those fractions are equal to each other, if those fractions are equivalent, when I take the denominators and multiply them to the opposite numerators, you should get a true statement. So that's what happens over here in this mini example. I have 2/4 equal to 3/6, and I take my denominators up to the opposite numerator. 2 times 6 and 4 times 3, and you have 12 equal to 12. So that's just proving that those fractions are equal to each other. All right. Let me erase some of this stuff so we can walk through it. All right. So he wants to fill in the blank with equal or not equal. The first one is 18 over 39 and 6 over 13, and we want to compare to see if they're equal or not. So you take your denominators up, and we see we have 18. I don't know why I'm erasing all this stuff now, but we have 18 times 13, which is 234, and then 39 times 6, which is also 234. So since they are equal, that means that your two fractions are equal. All right, any problems with that? Everybody good? Then you do the same thing with this next one. We have 5 over 7 and 7 over 9. Take your denominators up. That gives me 5 times 9 on the left, 7 times 7 on the right. So that's 45 and 49. They're not equal, so it means the fractions are not equal. right, any questions? You got a chance to finish writing. All right. Next thing we got going on is simplifying fractions. So when a fraction is in lowest terms, that means when the numerator and denominator of a fraction share no common factors other than 1. So we have 4/6. I can break up 4 and 6 into 2 times 2 and then 2 times 3. 2's can cancel. 2/2. You say cancel for lack of a better word, but 2/2 is equal to 1. So then it just breaks down to 1. That leaves us with 2/3 as our most simplified way of expressing that fraction. All right. So if they give us fractions and directions just say simplify, we have 6/10. We can take the same thought process that we had with the 4/6. 6 we can break up into 2 times 3. The 10 we can break up into 2 times 5. So if you notice what I'm doing here is that I'm breaking up each number into prime factorizations, the prime factorizations that we mentioned earlier. And whatever they have in common, I'll go ahead and cancel those out. And you're left with what they don't have in common. So the 2's cancel, leaving us with 3/5. Now, eventually you'll get to the point where, and you probably already can do it when it comes to, smaller fractions like 6/10. You don't have to write it all out, or you don't have to break them down to prime numbers. If you see something greater, you'll go ahead and cancel that out, and that's fine. If you're there, then that's great. But if you're not, or you have unfamiliar numbers, then it will always work if you break them down to prime numbers. So we look at that, for an example, if we look at that 170, 170 is 17 times 10. 17 is prime, but 10 I can break up into 2 times 5. And that's where that came into play. 2 times 5 times 17. Oh, I broke it up down here. Didn't even know. Okay. I'll erase that then. I'll use that space for another time. But yep, so I broke it down to 170 into 102. 102 is 2 times 51, then 51 is 3 times 17. So that's 2 times 3 times 17. The 2's cancel, and the 17's cancel, leaving you with just 5/3. All right. So the next one is what I was mentioning when I say if you don't break them all the way down to prime numbers, but you see something larger that you can break it up into. So when I look at 20/24, if those are familiar numbers with you or familiar numbers to you, and you say, hey, instead of breaking them all the way down to 2's, I can break it up into just 4 times 5 and 4 times 6, and recognize that the 4 can cancel, and that'll leave you with 5/6. So once you get familiar with the process, or if you know numbers or you have numbers that you're familiar with, If you don't want to break them all the way down to prime numbers, then that's fine. But as long as whatever is left, like this 5/6, nothing can reduce. Nothing can reduce in it, or they have nothing in common. And so here I was just showing the process if I broke them down to prime numbers. 2 times 2 times 5, 2 times 2 times 2 times 3. Cancel out the double twos in the top and bottom. That leaves you with 5/2 times 3, which is still 5/6. All right. Problems before we go to the next one. All right. Hold on. Okay. All right. Next one, 75/25. You can handle that one of two ways. 25 divides into 75 evenly. 75 cent. You got 25, 3/4. Look at it that way. But if you want to break it down using your fraction work like we've been doing, 75 is 3 times 25. 25 is down bottom. That 25 will cancel. Whenever something cancels out completely, a 1 is left there. And so that's what happened in our new denominator. That 25 cancels out completely and leave you with a 1. So that's 3/1. But any number over 1 is still just 3. So that's why we have a 3 as our final answer. And then 12/60. 60 is 5 times 12. So if you cancel out the 12, once again, 1 is left in that numerator. But this time it'll be 1/5. So be careful here. Sometimes people forget about that 1 in the numerator, and they will just write the answer 5, and that would be incorrect. So the answer is not 5. The 5 is actually in your denominator. So make sure you're careful with reducing that fraction. All right. Thanks. Nope, got a few more. Okay, so this next one, 1700/300. Once again, we have some zeros in the back. Whenever you have that, then you actually cancel those out and then reduce whatever's left. In this case, 17/3 was what was left. So there was nothing else to reduce. But remember those zeros in the back just represent multiples of 10. So really you had 100 back there, 100/100 that canceled out and left you with 17/3. All right, let me erase this stuff. All right, next one we have 10xy/6x. So I broke it up in this next part of the expression as 10 times 5 times 2 times 5, times x times y, 2 times 3 times x. And then we can cancel out what they have in common. So we see we have 2's in common, then x's that are in common. And that leaves us with 5y on top, and then just the 3 down bottom. Okay. So the last one out of this section, we have 2a cubed over 4a to the fourth. So I broke them down to prime numbers and expanded out our variables according to their exponents. So we have 2 times a times a times a, then 2 times 2, and then a 4 times a. And then from there you cancel out what is in common. So you have the 2's that cancel. That leaves a 2 down there. And then the a's that cancel. So up top, everything canceled, and that leaves you with a 1. Down bottom, we have 2 times a still left. So that result would be 1 over 2a. All right, somebody. Oh, got it. All right, appreciate that. All right, any questions before we go to 4-3? So that's it for 4-2. Now we're looking at 4-3. All right. So we're looking at multiplying and dividing fractions. All right, somebody says something in the chat. We have to complete the next test after this class. No. Right now you're just working on your homework. Let me check the test because last time I looked, he hadn't even posted. So he may have posted since then. So let me check on that, and I'll have an answer about tests by next class. I'll put a date on it and all this stuff like that. So yep, thank you for asking that. Great question. All right. So let's look at multiplying and dividing fractions, then call it a day. Never know, might not finish it, but we'll see. Multiplying your fractions. All you do is multiply across. That's a times c over, well, we have a over b times c over d. Multiply across, that would be ac over bd. All right, somebody said something. The homework is on Connect Math. Yep, all of your homework and all of your tests will be generated through Connect Math. Yep, even your final exams are going to be generated through Connect Math. All right, so we can multiply one of two ways. Let me delete some of this stuff so we can talk. All right, so we can either multiply and then reduce, or we can reduce first and then multiply. So the first method, if we just multiply across, that's 2 times 9, then 3 times 8 down bottom. That'll give me 18 over 24. Now I need to examine 18 and 24 and see, can I reduce? And we can. Both of them have 6 in common. So I can cancel out the 6, and that'll leave me with 3/4. So that's multiplying first and then reducing. That method is fine. You'll always get the right answer as long as you do it correctly. Only problem with that is that once you start dealing with large numbers, that way may not be the most comfortable, or they may present numbers that are unfamiliar to you. Then you have to try to figure out, okay, what do they have in common? And you might have to figure out the breakdown. But when you look at method 2, if you cancel first and then multiply, or in other words, reduce first and then multiply, you're dealing with numbers that are more familiar and it's easier to handle. And then you can cancel, well, you can cancel first and then go ahead and multiply out. So what I mean by that is when we look at 2 over 3 times 9 over 8, if I break them down into prime numbers, and sometimes it helps us to see it better, whatever's in common with the top, I can cancel out with anything that's in the bottom. So if I have a number up top, I can cancel out with anything in the bottom, as long as it's in common. So if I look at this 2 right here, I can cancel out with one of the 2's here. Then if I cancel out this 3 with this 3, that's the same thing as 2 times 3, which is this 6 that I canceled out. And what that leaves us with is, since everything canceled out in this first one, it's just a 1 here. And that leaves me with 3. And then 2 times 2, which is 3 over 4. So I would suggest that you get used to the idea of canceling first and then reducing, because it would allow you to deal with smaller numbers. All right, so let's do a few. All right, so these first two, the first one we have 2/5 times 4/7. There's nothing in common with any of them, not as far as the top and bottom is concerned. So yes, there's the 2 and the 4, but you want to be able to cancel out with something that's in the bottom, the top and the bottom. You can't cancel across. So if both of them are in the numerator, then you can't cancel those out. So in this case, we just multiply across. 2 times 4 is 8. 5 times 7 is 35. Second one, same type of thought process. We have negative 8 over 3 times 5. So that 5 as a fraction is 5 over 1. And then we just multiply across. Negative 8 times 5 is negative 40. 3 times 1 is 3. So it's negative 40 over 3. All right, any problems? All right, so the next one, we have 4 over 30 times 5 over 14. So I broke each one of them up into, prime factorizations. 4 is 2 times 2. 30, 2 times 3 times 5. And that breakdown is right there. 6 times 5, and then break down to 6 into 2 times 3. 5 is a prime number, so that stays the same. And then 14 is 2 times 7. All right. So then you cancel out what's in common with the top and bottom. So you have 1, 2 that's here, another 2 here, and then 5 can cancel out here. So don't forget, if everything cancels out, that leaves you with just the 1. So in the numerator, it's just 1 times 1. Denominator, we have 3 and 7. As a matter of fact, let me do this. Oh, that's just 1 over 3 times 7, which is 21. All right. Questions? Any questions? Once again, don't let me scroll up too fast if you still copying. Or you're going to review the video later. That's all good as well. So this next one, 10 over 18 times 21 over 55. So this is one of those situations most definitely wherein reducing in the beginning or reducing first is better than multiplying first, because of the numbers that you may be presented after you do your multiplication. So I broke down the 10 into 2 times 5. Then I broke down 18 into 2 times 3 times 3. 21 is 3 times 7, and then 55 is 5 times 11. Then from there, we just cancel out what's in common with the top and bottom. We have 2, 3, and then 5. So that leaves us with 7 on top, 3 times 11 on bottom. I think I want a better color than that. Yeah, I'm just playing with colors while you guys are finishing up. All right, before we look at division, any problems? Division is very similar to multiplication, it's just one extra step, but the process is very similar. All right, so dividing fractions, the first thing just wanted to mention was reciprocals. That's just flipping of your fraction. So if I have 2/5, when you flip the fraction, you get 5/2. That's the reciprocal. Both of them are reciprocals of each other. Same thing with -10/7. The reciprocal is -7/10. And then the reciprocal of 8 is 1/8. All right. So, that was just note 0 does not have a reciprocal because 1/0 is undefined. So don't forget that. All right. So when it comes to dividing, you're actually multiplying by the reciprocal. Let me see, is there somebody saying something? Yes, Miss Moultrie?
By you saying zero doesn't have a reciprocal, so if we was presented where zero was like somewhere in the fractions and we had to divide, will we not flip it or we just change the sign?
Well, no, 0, if you divide anything by 0, it's undefined.
Undefined, yeah.
Mm-hmm.
So
Yep.
we
So
wouldn't
that's,
flip the fraction or nothing.
nah, you wouldn't even waste your time. If
Oh,
0, in other words, let me go back to the notes because I had to. So if I have, oh, give me my pen back. Okay, there we go. 5 divided by 0, you don't even waste your time. That's just undefined.
okay, gotcha.
Mm-hmm. All right. So A over B divided by C over D. Some people like to say keep, change, flip, so that's why I wrote that right there. Somebody had mentioned it, but that's just A over B. You keep that the same. Change division to the multiplication, and then you flip the one that follows the divisional sign. So, like I said, some people like to lean on the words keep, change, flip. Once again, you keep the first fraction the same. The division changes to multiplication, and you flip the fraction that follows the divisional sign. So that's how you will divide fractions, by multiplying by the reciprocal. So looking at that first example, 2/3 divided by 9 over 8, that changes to 2/3 times 8 over 9. So once again, division, well, once again, your 2/3 stayed 2/3. Division changed to multiplication, and then 9/8 flip to 8/9. Once it changes the multiplication and flips and all that stuff, once you set that up, then all you're doing is following your multiplication rules. Everything that we did in the previous examples about multiplication, you follow those down here with division. But first, once again, you have to change that division sign to multiplication and flip the fraction that follows the divisional sign. And then notice what we did here. 2 times 8 is 16. 3 times 9 is 27. There was nothing that could reduce between the two numbers. All right, so 2/5 divided by 7/4, or 7/4. So 2/5 stays the same. Division changes to multiplication, and then 7/4 turn to 4/7. Multiply across. 2 times 4 is 8. 5 times 7 is 35. All right. Next one, 2/27 divided by -8/15. Once again, 2/27 stays the same. Division changes to multiplication. -8/15 changes to -15/8. Multiply across. Well, I went ahead and reduced first. I broke down. 2 stays the same. I broke down 27 into 3 times 3 times 3. 15, I broke it up into 3 times 5. And then 8 is 2 times 2 times 2. All right. You got a 2 that will cancel out. You have a 3 that will cancel out. Let me go another color. Let's go. So what you're left with is 5 in the top, and 3 times 3 and 2 times 2. So 3 times 3 is 9. 2 times 2 is 4. So 9 times 4 will give you that 36 down bottom. All right. Questions before we look at the next one? We only got a couple more left, and we'll be done. Here we have 35/14. This might be the last one. That's the last one. All right, so we have 35 divided by 7. So 7 as a fraction is 7/1. So we flip it, it turns into 1/7. Here I broke down the 35 into 5 times 7. 14 breaks down into 2 times 7, and then you have 1/7 in that other fraction. Now this 7 up top can cancel out with either one of these 7s down bottom. It doesn't matter which one you cancel it out with. Just remember that you can only cancel out once. So that's 5 times 1 up top, 2 times 7 down bottom, 5/14. All right. All right, next one, -12 divided by -8/3. So once again, the process, 12 stays the same. I went ahead and wrote that over 1 so it can be seen as a fraction. Division changes to multiplication. Then I flip the negative 8 over 3, and that's negative 3 over 8. From there, I go ahead and do that back. I break down the 12 into negative 2 times 2 times 3. Break down the 8 into 2 times 2 times 2. So 2 cancels, second 2 cancels. Then also recognize negative times a negative is positive. So they will cancel. So 3 times 3 is 9 on top, and then that just leaves us with a 2 on bottom. Any questions? Any questions? More? Okay, so this is the last one right here. Let's see how many more I got up here. All right, so let's look at this last one, unless you guys want another one. We have negative 10x squared over y squared divided by 5 over y. Once again, make sure you implement the process of division. So division changed to multiplication, and you flip that 5 over 1 to 1 over 5. I went ahead and broke down to the 10x squared to 2 times 5xx, and then the y squared to y times y. All right, so 5's cancel, one of the y's cancel, and that'll be negative 2 times x squared over y. All right. Any questions on anything that was said today? Everybody good? Everybody straight? All right. So we have that's it for today. We have a couple more sections out of chapter 4. Let me go back and look at about 2 or 3 more sections in chapter 4. And then, like I said, next class we'll talk about what we're gonna do about that test and all the stuff like that. I gotta check to see what the course coordinator has posted, and then we'll go from there. But nothing is due right now as of yet, so you guys are good to go. But make sure you guys are doing whatever trying to keep up with the lecture as you progress throughout the class, and you guys will be all right. Okay, great. Thank you. Thank you. So I will see you guys on Wednesday, and we'll go from there, y'all. You guys have a great day.
You too.
Thanks. Appreciate it. Thanks. You do the same.